Now, the first example of the motion of connected bodies, we are having two blocks, block 1 and block 2. Block 1 is of mass capital M, block 2 is of mass small m, and these are tied to the two ends of inextensible string which is placed over a pulley. Now, when it is placed over the pulley, capital T is the tension developed in the wire, and now the block 1 and block 2 are having different masses. The mass of block 1 is greater than block 2. So the block 1 will move in downward direction and block 2 will move in the upward direction. Now we will see the forces acting on the block 1 and block 2. Now for the block 1, the weight mg is acting in downward direction. The force due to acceleration in downward direction and the tension T in upward direction. तो इसकी इक्वेशन क्या बनेगी बैलेंसिंग ऑफ फोर्सेस की? कैपिटल एम ए इज इक्वल टू कैपिटल एम जी माइनस टी. अब जो हमारा ब्लॉक 2 है विच इज मूविंग इन द अपवर्ड डायरेक्शन, इट इज ऑल्सो हैविंग थ्री फोर्सेस, वेट एम जी इन डाउनवर्ड डायरेक्शन, tension T in upward direction and force due to acceleration in upward direction. So the equation we have is small m a is equal to T minus mg. Now we have to find the value of the acceleration with which the blocks move and the tension in the string. For this, first of all, we will add equation 1 and 2. We get capital M A plus small m a is equal to capital M G minus T plus T minus mg. Rearranging, we get capital M plus small m into A is equal to capital M minus small m into G. So we get the value of A as capital M minus m upon capital M plus m into G. This is the value of the acceleration. To find the value of tension, we will divide equation 1 and 2. We get capital M A upon small m a is equal to capital M G minus T upon T minus small m g. A and A will cancel out. We will cross multiply. We will get capital M into T minus small m g is equal to small m into capital M G minus T. Rearranging, we will get capital M T plus small m t is equal to 2 capital M small m into G. From this equation, the value of tension will come out to be 2 capital M small m G upon M plus capital M plus small m. So this is the value of acceleration and tension. If you have the situation of connected bodies, you have to treat the bodies individually and make the equations of the forces which is balancing on each body. Now we are going to do two numericals which are based on the connected bodies. Now we are going to discuss two numericals on connected motion. Now the first question is, a wooden block of mass 2 kg rests on a soft horizontal floor when iron cylinder of mass 25 kg is placed on the top of the block and cylinder together go down by an acceleration of A is equal to 0.1 meter per second square. Find the action of block on floor before and after placing the cylinder. So here in this, what is the situation? A block is placed on a soft floor, and when we place the iron cylinder on the block and the cylinder moves down the soft floor with an acceleration of 0.1 meter per second square. We have to find what is the action of force, what is the action of block on the floor before and after placing the cylinder. So first part is when we have not placed the cylinder. In this case, the forces acting on the block are the weight of the block downward and the reaction in the upward direction. So the value of reaction will be as the no external force is acting on the block. So the reaction will be equal to weight, which is equal to W is equal to mg, where m is the mass of the block, that is 2. 10 here, acceleration of gravity is given as 10 meter per second square. So we have weight as 20 Newton. So the force exerted by block on the floor will be same as the reactional force, which will be equal to 20 Newton. Now in the second case, when we place the cylinder, we have a third force, that is force due to acceleration A. So here we have three forces. R dash is the reaction force in upward direction, mg is weight in downward direction, A is acceleration in downward direction. So we will have the force due to acceleration is equal to, जो acceleration force है वो किसके equal होगी, the weight, the force due to weight minus R dash. R dash is the reaction force, and when we will calculate the reaction force, we will have mg minus ma. Here m is the total mass of the system, that is the mass of the block plus the mass of the cylinder, that is 27 kg. So here the total mass in this case will be 27 kg, and capital G की value है 10, small a की value है 0.1. So we get the reaction force as 267.3 Newton. So the total force exerted by this system on floor will be same as no external force is acting, which is equal to 267.3 Newton. Now in the second question we have tied two blocks of masses m1 and m2 by a string. Now what we have done in this question, we are applying force first on the block m2, then block of mass m2, that is B block, and then in the second case we are applying force on the block of mass m1, that is A block, and we have to calculate the tension in the string in the two cases. Now in the first case, when the force, here we have two blocks m1 m2 tied by a string, and we have assumed that the tension in the string is T1, and the mass of one block m1 is 10 kg and m2 is 20 kg. Now when the force is applied to the block m2, if we take the block m1, the only force which is acting on the block m1 is the tension force. So we have T1 is equal to m1a, where A is the acceleration produced in the system, and in the second case when force is applied to block A, that is of mass m1, the total tension, which is the only force on m2 is the tension, that is T1 is equal to m2a. Now we are having the value of m1 and m2. We will calculate the value of acceleration. The acceleration will be equal to force upon total mass. Here in the question the force has been given as 600 Newton. So the acceleration comes out to be 20 meter per second square, and by putting the value of mass and acceleration, you can simply find the tension in the two cases. Friends, after discussing the connected motions and the numericals on connected motion, now we are going to discuss the frictional force. First of all, I will tell you what is frictional force. Frictional force is a force which comes into play whenever a body moves or tends to move on the surface of other body. Suppose this is a surface, and if we place a block here and try to move that block on this surface, then there will be a force opposing the motion of that block on this surface. This is known as frictional force. So if we have a block here, this is our surface. If this is the direction of the applied force, means जिस direction में आप force apply कर रहे हो, opposite to that applied force there will be a force of friction that will oppose the motion of block on the surface. Now talking about friction, whenever a block, this is a block, when it tries to move on a horizontal surface, we have three types of friction which is acting, or three, you can say these are not actually the types, these are the phases of the frictional force which acts on the block. Now whenever the अगर हमारा जो फोर्स है वो कम है तो जो ब्लॉक है वो मूव नहीं करेगा. सो whenever we apply the force to move the block on the surface but it is not able to move, that force of friction acting in that case is known as static friction. अब सपोज करो जो दो बॉडीज हैं उनके बीच में फ्रिक्शनल फोर्स है 20 न्यूटन. सो द वैल्यू ऑफ द स्टैटिक फ्रिक्शन इज लेस देन 20 न्यूटन. एंड नेक्स्ट वी हैव लिमिटिंग friction. Limiting friction is the maximum value of the static friction after which the block will start to move. So as I have explained कि अगर हम लेंगे कि इन दोनों surfaces में जो maximum frictional force है, जो मतलब जिस frictional force को overcome करने के बाद this block will move on this horizontal surface is 20 Newton. So the value of static friction here will be less than 20 Newton. And the value of limiting friction will be 20 Newton and the kinetic friction will be greater than 20 Newton. मतलब the frictional force which will act after 20 Newton of force, that will be kinetic friction. Kinetic friction is the force of friction which comes into play after the block starts moving on the horizontal surface. So students, here you can see the graph. Here we have taken the force of friction on y-axis and the applied force on x-axis, and this graph shows the three phases of the friction. First, when the body is at rest, we have static friction and the maximum applied force after which the block will start moving is your limiting friction. And when the block starts to move or starts sliding on the horizontal surface, we have kinetic friction. So this is all about the friction and phases of friction on the horizontal surface. Tomorrow we will discuss about what are the other types of friction, and we will study the laws of friction, and we will study the rolling and the sliding friction. Okay students, that's all for